vice versa. We're going to see that, and I try my hardest to show that throughout the semester. So it's important that we learn both, because once we understand what each tissue or each cell does, it's easier to understand what that cell or tissue does when we see it again somewhere else in the body. Ultimately, our body is made up of a series of different structural organizations. We are the organism. But organisms are ultimately made up of a series of organ systems. This would be our digestive system, our cardiovascular system, the integumentary system, nervous system, what have you. All organ systems are comprised of a series of organs. Our digestive system, for example, is made up of the stomach and the esophagus and the small and large intestine. All organs are made up of tissues. All tissues are made up of cells, and all cells are made up of atoms. So, the smallest of all components of our organism is the atom, which is what we're going to be talking about a little bit in chapter 2. We'll do chemistry and we'll show the atom. We'll show how atoms combine to make molecules and compounds. We're going to talk about how these compounds turn into organic and inorganic substances and how ultimately that makes up who we are. The cellular level, if you take a bunch of atoms, put them together, we can create a cell. We're going to talk about the cell in greater detail at the beginning of chapter 3. Cells are ultimately going to give us very specific function. Each of the different cells has a very different function that allows it to do something different. And we use those differences to allow our body to be unique, and each organ system to be unique. If we take a bunch of cells and combine them together, we create something called a tissue. This is going to be what we talk about at the end of chapter 3. We're going to show you everything from the 3 types of muscle tissues to all the various connective tissues to the epithelial tissues. We're going to take a look at what brain tissue looks like. And each of these tissues has a very different function due to the fact that each cell has a different function. For example, what's the job of a muscle? Why do we have muscle? There's 3 types of muscle: smooth, cardiac, and skeletal. All of them do one thing in common, and what is that? They move. They help us to move. That's it. The job of a muscle is to produce motion. All right, obviously our skeletal muscle moves our what? They move our skeleton. The cardiac muscle, the muscle in our heart, what does it move? It doesn't move the heart. It moves the blood that's in the heart. And our smooth muscle, which is found in all of our hollow organs, moves whatever is in that hollow organ. If we have if it's our stomach, the smooth muscle moves the contents of the stomach. So all muscle tissue moves material, some way, shape, form, or fashion. And the reason why that is because each of these cells that make up all of our muscle tissues, they have the ability of getting shorter and longer. That's their physiology, right? And we're going to see that's going to be true for every different tissue that we talk about, which is what makes our body so unique. Now, if we take multiple varieties of tissue and we put them together and give them a common function, we get an organ. The book uses a blood vessel as an example, which is a fine example. But blood vessels aren't made up of one tissue. They're actually made up of 3 or 4 different tissues. There's a little bit of muscle, there's a little bit of connective tissue, and there's some epithelial tissue. Each of these layers has a different function. The epithelial layer of a blood vessel either secretes something or absorbs something, moves something, in some way, shape, form, or fashion. The muscle is all about motion, and the connective tissue here is all about protection. So we have 3 different tissue types, all with some common goal in mind. We call that an organ. If we take multiple organs and put them together, now we get something called an organ system. We're going to talk about all the different organ systems here in a second, all their unique components. But organ systems ultimately help us to have some greater function for the body, and organ systems all communicate with other organ systems to allow us as an organism to be better suited to adapt to our surroundings. And then again, if you take all these different organ systems, put them together, we get a girl kicking a soccer ball, otherwise known as an organism. It's who we are. So we're going to learn all of these. Chapter 2 is going to be chemical. Chapter 3 is going to be cellular and tissue. And then chapter 4 through 16 is all about organ system and the organs that are contained within. When we talk about all the different organ systems of the body, and we're going to take these in order that we're going to learn them. The first organ system we're going to learn about, I think it's chapter 4, is our integumentary system. And for now, I don't expect you to know anything great about any of these organ systems. What I do want you to know for the first lecture exam is, can you tell me the basics with regards to their function? And can you tell me the basics with regards to the organs that are contained within them? On the lab exam, on the first lab exam, there's going to be a time where they're going to say, I'll pick an easy one. The heart is part of what organ system? That'll be a question on the first lab exam. Or what organ system helps to regulate body temperature and excrete salts as perspiration? That would be they're going to ask questions to make sure you know the basics of each of these organ systems. The first organ system we learn is the integumentary system. This is our skin. This is our hair. This is our nails. And if you had to come up with one function, one key function of why we have skin, why we have hair, and why we have nails, what would be that function? One word. Protection. Our skin protects us. And it protects us from a whole host of different things. All right? First and foremost, our skin keeps out the things we want out. And it keeps in the things we want in. Secondly, our skin protects us from the sun. And it does so in a few different ways. All right? First and foremost, the different colors of the skin offer different protective layers from the sun's UV rays. The darker your skin is, the more protected you are from the sun. The lighter your skin is, the less protected you are from the sun. But the one thing all skin has the ability of doing is what? As we get exposed to more and more sun, what does our skin tend to do as a protective mechanism?
It tans.
It tans. We get darker. The reason why we tan isn't so that we have a cool beach tan to show off to our friends. The tanning that happens in our skin is a protective mechanism. It's our body saying, all right, you're getting exposed to more sun than we would really like you to be exposed to. So what we're going to do is darken your skin up, because we know the darker your skin is, the more protected you are from the UV rays of the sun. And we do that through something called melanin. Melanin is what gives us our skin tone, obviously determined by what mom and dad bring to the table. And then ultimately, the more melanin we produce, the more protected we are from the UV rays of the sun. If somebody comes up, like right now, my 13-year-old has the flu. And if I went up to see how my son was doing and he sneezed on my arm, would I get the flu? No. Because my skin's going to protect me from that virus from getting, my skin's not going to let that virus get through my skin. Now, if I take that arm and I do this, all bets are off, and I'm stupid for doing it, right? But our skin, by and large, protects us from the disgusting parts of our world, which there are plenty. Right? We live in a very disgusting place.
What about like skin burn? Sunburn.
Sunburn is when you actually fry your skin. All right, so when you think about the skin has 3 layers: epidermis, dermis, and hypodermis. If you burn the epidermis, that outermost layer, that's a sunburn. It's called a first-degree burn. So that obviously is an abnormal thing, right? That's no bueno, because that'll ultimately compromise that part of your skin for a period of time until you can correct the sunburn.
Right.
But it's kind of like putting a chicken into the oven and its skin getting crispy.
It's too hot.
It's too hot, right? Too hot for too short a period of time. Yeah. Our skin waterproofs us. It protects us from injury. It ultimately helps us to produce vitamin D. We take the sunlight and we can convert it into vitamin D. We do use our skin to help us get rid of metabolic waste. We do so by perspiring, specifically in our underarms and our groin. We help to regulate body temperature. This is coming from all the perspiration from your forehead and chest and back and arms. And our skin also plays an important role in allowing us to better understand the environment around us. We have a series of receptors in our skin which help us to recognize anything from temperature to pressure to massage to pain. All right, everybody here is wearing a ring or a bracelet or a watch, and when you put that on this morning, you knew where to stop squeezing your arm because there's receptors that said, all right, it's tight enough. Or your belt, you knew when the belt was tight enough because you could feel it. Those are receptors in the skin that help us to understand what's going on around us. So again, when you think of the integumentary system, we're thinking of the hair, we're thinking of our skin, we're thinking of our nails. Key function is it protects our body from the environment around us. It also helps us to regulate body temperature. It helps us to get rid of metabolic waste through perspiration. Easy enough system. The next one is our skeletal system. We should all know what our skeletal system looks like. Obviously, this is going to be all the bones of the body and the joints that are connected between them. When we think of our skeletal system, again, it's the bones, the ligaments, the joints. And the job of our skeletal system is kind of twofold. Two key functions. One is our skeletal system helps to provide a site for muscle attachment. And the muscles ultimately move our skeleton, which gives us locomotion and motion in general. The second big thing our skeleton does for us is it protects us. All right, think about the cranium surrounding our brain. Think about the eye socket, which surrounds our eyes, or the rib cage that surrounds our heart and lungs, our pelvic bone, which protects our internal organs, bladder, ovaries, uterus, prostate, what have you. It gives us something that it gives us a sense of protection. Our spinal column, protecting our spinal cord. Some of the lesser things that people don't really think about when they think of the skeleton is the last two bullet points. The first one is all of our blood cells, red blood cells, white blood cells, platelets, all of them are produced in our bones. In a part of our bone called the red bone marrow. And then we also use our bones as a mineral storage. What's the one mineral we always talk about? You hear it on the commercials. You know, this does a body good, pass it on. We're going to talk about milk. Calcium. Calcium is one of the, it's not the only thing we store in our bones, but one of the big things that we store in the bone is calcium. So if you are an avid milk drinker, just to pick something free and easy, right, the one thing you're providing your body with is a ton of calcium. And your body needs calcium for a lot of things. We don't just use calcium for bone production, right? We use calcium to make our nerve fire. Without calcium, muscles can't contract. We have a lot of things we use calcium for. So your body knows that if you dump a bunch of calcium into it, it doesn't know when you're going to give it more calcium. So any excess calcium, it's going to store for a rainy day. And the way that we store calcium is by putting it onto our bones and making our bones thicker. And in doing so, we have a little storage, a little kind of savings account, if you will, in case you decide not to drink milk for the next 2 weeks, right? So we store minerals, calcium being the big one. This will be chapter 5. The next chapter, chapter 6, is our muscular system. When we think about the muscular system, we tend to only think of the muscles that we exercise in the gym, right? Our skeletal muscles. But there's actually 3 varieties of muscles. There's skeletal muscle, which are the muscles that attach to our skeleton and give us all the motions of the body. There's cardiac muscle, which is the muscle that comprises the walls of our heart. And then there's smooth muscle. Smooth muscle is the muscle that's found in and around all of our hollow organs. Stomach, intestines, blood vessels, esophagus, pharynx, trachea, all of those have muscles, but those are all going to be called smooth muscle. Regardless of which muscle you're talking about, all of our muscles do one key thing, and they provide us with motion. Now, the muscular system we're going to talk about in greatest detail is skeletal muscle. We're going to talk about that in the greatest of all details, and that's what we see here. In Anatomy 1, we learn like 90 muscles, 90, 95 muscles. In Intro, it's probably 35 or 40 of them. So it's not nearly as many muscles. If you want to get a head start on the muscle chapter, I wouldn't do it just yet. I would wait until maybe the middle of this first section, since this is the part of Anatomy 2. But people always get worried about learning their bones and muscles. So if you want to learn them now, the sooner you learn them, the better. There's a list of muscles you're responsible for, pecs and all the abs and delts and traps and all that kind of fun stuff. But again, muscular system, regardless of which 3 types you're talking about, or the 3 types you're talking about, they're all about production of some motion. Our nervous system, which is the next chapter. Our nervous system is comprised of a few different things. We have our brain and spinal cord. We have all our spinal nerves. We have all our cranial nerves. And you can really break down the nervous system into three functions. Function number one, our nervous system needs to be able to detect changes to or within the body. So for example, right now it's hot as a sin in this room, right? And I know I'm not the only one who feels like this room is too hot. We know it's too hot because we can feel the heat. And the nervous system is what allows us to feel the heat. Even though it's our skin's receptors, those receptors are attached to the nervous system. If somebody came up to you and poked you with a stick, you can feel that because of your nervous system. You have to detect changes that are happening to or within the body. Our nervous system does that. The second thing, and that's the sensory receptors. The second thing is we need to make sense of those changes. So as things happen within our body or happen to our body, we need to be able to understand, A, what's happening, B, is it dangerous, and C, do we need to do something about it, and if so, what should we do about it? And that's the job of the brain and the spinal cord. And then the third thing the nervous system does is it actually does something to the body to ultimately take care of whatever change is happening. So, for example, we go outside on a hot August Houston summer day. It's hot as the hinges in Hades. Our skin detects that heat because that heat hits the skin and it stimulates receptors in our skin. That receptor sends information to the brain, telling the brain our body temperature is going up, which is no bueno. We don't like our body temperature rising. What does our brain do in response? We sweat. And what sweating does is it cools us down. It's a perfect example of what the nervous system does. It detected a problem, it made sense of the problem, and it did something to combat the problem. Right? That's the nervous system's job. And it does it pretty quickly too. If you're out in the Houston sun, you don't sweat like 45 minutes later. You sweat pretty much instantaneously. Right? Your body's very, very quick to respond. And that's what the nervous system does. And it does so utilizing the brain and the spinal cord and all the nerves of the body, which is what we see here. The next organ system, this will be the first chapter of the second half of this class, is our endocrine system. The endocrine system is made up of a series of organs and glands, all of whom produce and secrete chemicals called hormones. And all of these hormones ultimately tell the body how to function. And in doing so, it allows us to do everything from grow to reproduce. It allows for our body to function properly and for us to maintain something called homeostasis. And homeostasis is simply defined as the ability of our body to stay normal. A good example, do we have any moms in the house? Just the one. So only one crazy person in the house along with me. So you went into labor sometime or another in your life, right? Mm-hmm. So as your son or daughter? Son. So as your son was 9 months, putting pressure down on your cervix, and your cervix began to stretch, right? Mm-hmm. And you told somebody, hey, I got to get to a hospital because this kid's coming tonight, right? Your baby pushing on the cervix was causing your cervix to stretch, which is abnormal, right? That's not supposed to happen. Cervixes are not supposed to stretch. But that signal went to the brain, and the brain said, I bet you it has something to do with that 9-month-old baby in her uterus. So the brain told an organ in your body called your pituitary gland to secrete a very important hormone called oxytocin. Oxytocin, which is released from the pituitary gland, traveled through your bloodstream to your uterus and told the muscles of your uterus to do what? Contract, which put you into labor, right? So here we have a problem in the body, cervix is stretching. The brain determined, all right, well, that's because there's a baby coming today. This organ or gland, the pituitary gland, secreted a chemical that's known as a hormone. The hormone's name is oxytocin. That hormone went to her uterus and told the muscles of the uterus to contract. And you contracted that uterus until such time as your son was born. All right? So here's a gland secreting a chemical, telling the body to do something different in order to make homeostasis happen. And the endocrine system is nothing more than a series of glands and organs that secrete a series of different hormones, all of which have a different function. For example, after you eat food and you dump all that food into your bloodstream, our blood sugar levels skyrocket, right? That's supposed to happen. What hormone does our pancreas release to take our sugar levels and lower them in the blood? Insulin, right? Insulin is a hormone secreted by the pancreas to ultimately take the sugar in our blood and push it into our cells. So that we lower our blood sugar to normal levels, and our cells get fed, so our cells can then take that sugar and do what they're going to do with it, primarily produce energy. So when we get to the endocrine system, it's going to be a series of organs and glands. Here are the hormones it releases. Here's what each of these hormones do. And when we think about the different organs and glands of our endocrine system, our pineal gland, which secretes melatonin to help us sleep, pituitary gland secretes 9 different hormones, all of which have a wide variety of function, from labor to controlling water in the body, to helping our thyroid and adrenal glands function, to helping us to grow, produce sperm and testosterone, produce eggs and estrogen, all kinds of different functions. Our thyroid gland, thymus, adrenal glands, pancreas, testes, ovaries, all of these are organs and glands that produce some hormone that allows our body to better function. Goodness gracious, over there. Oh shoot, we're pretty much done. All right, we'll finish this up in lab. Lab again is 2:30.